Hi everyone, and welcome to our next lesson. So on Unit 3, we've been talking about atomic structure. This lesson is going to be about something called subatomic particles. And this lesson is basically going to take us through to Thanksgiving break. So yay, Thanksgiving break, but first, subatomic particles. So a quick overview. Subatomic particles are things we've encountered already, but I want to look at that word sub a little bit closer. That's a prefix that means below, meaning these particles are smaller than atoms. They're subatomic, smaller than atoms. And those are what we've encountered already, protons, neutrons, and electrons. So in this lesson, we're going to see them a little bit more closely. And then we're going to talk about the periodic table. So we've seen the periodic table of elements a number of times, and you've seen a bunch of different things on there, including the atomic number and mass number without really knowing it, including elemental symbol and elemental name. So now, for the first time, we're going to understand what some of those things mean. So the proton, we know the proton that we can see down there in our little picture of Rutherford's nuclear model of the atom, is a positively charged subatomic particle. So what does it mean to be positively charged? Well, it means that basically for each proton you have in your atom, the charge increases positively by about 1 charge unit. And where's the proton located? Well, it's located in the atom's nucleus, but like we know already. So location down there says nucleus. And it has a mass of 1.672 times 10 to the negative 27 kilograms. So that number is really super duper tiny, considering that it has 27 zeros before that first 1 and 1.67, and that's a really small decimal, and that's why we express it in scientific notation, and why we spent the time learning that lesson. But that's really an inconvenient number to work with. So instead of working with the mass of a proton in kilograms, we're going to start using this mass called atomic mass units that we'll talk a little bit more about later. But what you got to know now is that protons have an atomic mass unit of about 1.0073. So we're going to say that their mass is just about 1 AMU. So our next subatomic particle is the neutron, which is pictured down there in our nuclear model of the atom. And neutrons are neutrally charged subatomic particles. So neutron, neutral, that's how you can remember that. And what that means is that for each neutron that you have in your atom, the charge of the atom overall doesn't change. So neutrons have a charge of 0. And as we know, neutrons are located in an atom's nucleus, and they also have a mass of about 1.67493 times 10 to the negative 27 kilograms. So that's similar to the mass of a proton, a little bit more, also really small in kilograms and not very easy to work with. So instead we're going to call that 1.0087 atomic mass units. So the mass of a nucleus is very similar to a proton, also about 1 AMU. So we don't want to talk about, oh, I'm sorry. So this up here should not say neutron, this should say electron. Anyway, so our electron, this is really where all the interesting stuff happens, where the chemistry is going to go down through electrons. And electrons are negatively charged subatomic particles. They're located outside of the atom's nucleus, but we'll talk about that in a second. What it means to be negatively charged is basically that for each electron you have in your atom, the charge decreases by 1 charge unit. So protons added 1 to the charge, neutrons didn't change the charge, and electrons decreased the charge by 1. They're located outside of the atom's nucleus, and that's unlike protons and neutrons, which are inside the atom's nucleus, and they have a mass of 0.00091 times 10 to the negative 27 kilograms. So that's even smaller than protons and neutrons. In an atomic mass units, that's 0.00055 AMU. I'm sorry. So the mass is just about 0 AMU. So taking all that information, let's put it into a quick table. We know the charge of a proton is +1. Each proton is going to increase our charge of the atom by 1. The charge of a neutron is 0. More neutrons, not going to change our overall charge. Charge of the electron is -1. And each electron we have in there is going to decrease the charge of our atom by 1. So the protons and neutrons we know are located in the nucleus, but the electrons are located outside the nucleus, and the mass of protons and neutrons are both about 1 AMU, so each proton and neutron in your atom is going to increase the overall mass of the atom by 1. And electrons, basically compared to the size of protons and neutrons, are so small that adding electrons to our atom isn't going to change the mass. So it has 0 AMU of mass. So, like it says at the top of this slide, atomic number defines what element we're working with. Well, what's atomic number exactly? First, let's go back to some things we talked about last lesson. We know that an atom's number of protons determines its elemental identity. In other words, an atom of the same element has the same number of protons. So if you'll remember, that's what our guy Dalton said. And that's why this atomic number is so important. So we refer to atomic number as Z, and atomic number is the number of protons in an atom's nucleus. So here, pictured down at the bottom right, we have a hydrogen atom. How do I know that it's a hydrogen atom? Because it has 1 proton, and the atomic number for hydrogen is 1. So we say that Z equals 1 for hydrogen. So the periodic table of elements arranges the elements according to increasing atomic number. And we don't just have atomic numbers on the periodic table of elements, we have the elemental symbol, which is 1 or 2 letters symbol representing each element. We also have the name, which is the word representing each element. So let's zoom in on our periodic table. To the top right corner, you'll see something like this. And I want to focus on this element right here called helium. So helium is the element that if you breathe in, makes your voice sound really high-pitched and funny. And how do I know that this entry here is helium? Well, it has the elemental name right there. And in addition to the elemental name, you have the elemental symbol for helium, which is He. So elemental symbols will always have a capital letter first, and if it has a 2-letter symbol, the second letter will be lowercase. And that number 2 right there is helium's atomic number. So we know Z equals 2 for helium, and helium has 2 protons in its nucleus. So any atom with 2 protons in the nucleus is going to be a helium atom. Number of electrons. So atoms are overall neutrally charged. What does that mean? That means that the total positive charge equals the total negative charge in an atom. And we only know 2 things in an atom, one each that has a positive charge and a negative charge. And protons have a positive charge, electrons have a negative charge, so we know that the number of protons in our atom is going to equal the number of electrons in our atom. So that's how you can determine how many electrons you have in your atom. So number of neutrons, same idea. Protons have a mass of 1 AMU, neutrons have a mass of 1 AMU also, electrons have a mass of 0 AMU, which means the protons and neutrons determine an atom's mass. So the mass number is the total number of protons and neutrons in an atom. That means that the total number of protons plus the total number of neutrons equals the mass number. And if we rearrange that equation down there, we know that the mass number minus the total number of protons equals the number of neutrons. So you can find the number of neutrons according to that equation there. But we know that the number of protons is just another way of writing the atomic number. So you can also say the neutrons equals the mass number minus the atomic number. So here's a little mnemonic to remember that. It's called 8-man, which tells us that the atomic number equals the number of protons, which in a neutral atom has to equal the number of electrons, and the mass number is the minus the atomic number equals the number of neutrons. So remember 8-man to do some of these calculations.